The volumes of prisms. A prism is a solid object that has a flat base from which it rises up to a certain height. The top and the bottom are the same size and shape as is every horizontal slice. For examples, let's say a box. A box is something that has a rectangle for a top, the same shape rectangle for the bottom, and it rises straight up and down to a particular height. So, and what I mean by every slice, if you were to slice it, every single slice is the same as the top and the bottom. Another kind of prism is a cylinder. A cylinder has a circle for a top and the same circle for the bottom, and it goes straight up and down between the two. And every single slice is a copy of that circle. A triangular prism has a triangle on the top and rises straight up and down and has that same triangle on the bottom. There's many different kinds of prisms. Anything you can possibly think of. A trapezoidal prism. Trapezoid top and bottom, goes straight up and down between them. The cool thing about prisms is that the volume of a prism is always area of the base times the height. So, if you know your areas of shapes, you know your volumes of prisms. It's pretty easy. What is the shape of the bottom of a box? Also known as a rectangular prism. A rectangular prism. It's called a rectangular prism because the top and bottom are rectangles. Well, it's length by width. And it's got some height h. So what is the volume here? It's the area of the base. Length times width times the height. Length times width times height. Length times width times height is the volume of a box. A cylinder, if it's got a height of h, what do we need to know? We need to know what is the radius of the base. What is the volume? The volume is the area of the base times the height. The area of a circle is pi r squared times the height. That's the volume of a cylinder. Triangular prism. Well, we're going to need to know what is here's the problem. If I'm going to say that the height of this triangular prism is h, then I'm going to have to use a different letter than h for the height of the triangle. A lot of times we'll call it the altitude of a triangle. So there's the altitude of the triangle, and we need to know the base of the triangle, but once we've got those dimensions, we can say that the volume of the triangular prism is area of the base, 1/2 base times height, or height times base, AB times the height. So these are useful formulas. I think it's so much more useful to remember one formula than to remember 4. 1, 2, 3, 4. So now a cube. A cube is just a very special kind of rectangular prism. Length times length times length. Right. Here's the height. The area of the base. The base is just a square. So the volume is length times the height, which is the length. And that gives us length cubed, as we were using in the Delian problem. So let's just do a couple problems. Let's say you have a trapezoidal prism. I like trapezoidal prisms. Why do I like trapezoidal prisms? Because I can check whether you know the volume of the area of a trapezoid and the volume of a prism at the same time. Let's say that this is 8 inches tall, and it is 20 inches across the front, and it is 6 inches across the back. And if I found the height between those two, let's say that was 5 inches. What is the volume of this object? The volume is the area of the base times the height, as it is for all prisms. And the area of the base is, well, it's a trapezoid, so it's 1/2 base 1 plus base 2 times, well, the height of that sort of thing. We'll call it h1 times h2, but in this particular case, what is it? 1/2 one of the, this is 6 across the back, right? So it's 20 plus 6 times the height here, which is 5 inches, times the height of the whole thing, which is 8 inches. And what is this? This isn't so bad. This is, what, half of 26, which is 13, times 40. And 4 times 13 is 40 plus 12 is 52, and multiply by the 10, 520 cubic inches. As I've said before, I'm going to make a big stinky deal about units on the next test. And I want you to say inches, and I want you to know that all volumes are cubed. All volumes are cubed. And, I don't know, let's do a cylinder. Let's do a cylinder and wrap this one up. We've got a cylinder, and it's got a radius of 6 centimeters, and the whole thing has a height of 2 meters. You say, what a jerk you are. You have to know that 2 meters is 200 centimeters, and then we can find the volume. The volume is area of the base, pi r squared times the height, and so this is pi times 6 centimeters squared times the height of 200 centimeters. You don't have to include your units when you're working these things, but if you do, you're going to get what? Pi times 36 square centimeters times 200 centimeters, and 2 times 36 is 72, with 2 more zeros. 7200 times pi centimeter cubed. You can plug in pi as 3.14, or you can leave this as your answer.